Hello students, welcome to AskPrep. My name is Gagana. Today I'll be teaching you the first chapter of class 11 Indeed. If you have any doubts, please feel free to ask in the comments. So let's get started. So in the previous class we have discussed about the significant figures, scientific notation and international system of units. So in this today's class, we'll continue with the further addition and subtraction of significant figures. So the result cannot have more digits to the right of the decimal point than that of the original number, which has the least number of digits to the right of the decimal point. For example, it is 12.11, 18.0 and 1.012. So obviously the result would be 31.122. It is rounded off to as it is only one decimal point after the 0. So the answer is 31.1. So the next is multiplication and division of significant figures. In these operations, the result must be reported with no more significant figures as than the measurement with very few significant figures. So if the product should not have more than two significant figures if the reactant has only two significant figures. For example, 2.5 into 1.25, you get 3.125. So next is the rules in the rounding of the numbers. The digit on the extreme right, that is the last digit of a number, may be removed. So if you have to remove the rightmost digit, which is more than 5, the preceding number should be increased by 1. For example, 1.386. It is equal to 1.39. As the preceding digit, that is 8, is greater than 5, you can round it off to the next number, that is 9, and it is 1.39. So if the digit to be removed is less than 5, the preceding number is not changed. So if it is less than 5, no need to change. You have to, if 6.35 is to be rounded up by removing 5, we have to increase the rounded off to 6.2 only. So as it is less than 5, you should not increase. You have to keep the value as such. For example, 4.334, it is 4.33. If the digit to be removed is 5, then the preceding number is not changed even if it is an even number, but it is increased by 1 if it is an odd number. So if it is an even number, you need not to change. So if it is an odd number, for example, if it is 6.35, then you have to make it to 6.4. So the next concept is dimension analysis. So while calculating, we need to convert the units from one system to another system. So the method which is used to accomplish this is called factor label method or unit factor method or dimensional analysis. So the next concept is laws of chemical combination. So what is the law of chemical combination? How the formation of compounds takes place on the following basic laws are studied. So the first law is law of conservation of mass. The second law is law of definite proportions or constant composition. The third law is law of multiple proportions. Fourth law is Gay-Lussac's law of gaseous volumes. And the fifth law is Avogadro's law. The first law is law of conservation of mass. See, law of conservation of mass was introduced by Anthony Lavoisier. He stated that matter can neither be created or not be destroyed in a chemical reaction. So, how much ever reactants you are adding in a reaction, so much ever products is formed. So here sulfur plus Fe, if you add and heat, you get ferric sulfide. So 32 gram of sulfur, 56 gram of iron, you get the product as total is 88 gram. So how much ever is present in the reactant side, so much ever is present in the product side. Law of definite proportion. It was proposed by Joseph Proust. A given compound always contains exactly the same proportion of elements by weight. Example is of cupric carbonate with respect to different proportions and percentages of weight are given below. Natural sample percentage of copper is 51.35, whereas in the synthetic sample also it is the same. Percentage of oxygen 9.74, here also 9.74. Percentage of carbon 38.91, here also it is 38.91. So the next law is law of multiple proportions. See, it was proposed by John Dalton. See, according to this law, if two elements combine to form two or more than two compounds, then the masses of one of the elements that combine with the fixed mass of the other element, see, they are in the ratio of small whole numbers. So, for example, hydrogen combines with oxygen to form two compounds, namely water and hydrogen peroxide. See, hydrogen plus oxygen will give rise to water. So, if hydrogen is 2 gram, oxygen is 16 gram, water is 18 gram. And in another example, hydrogen plus oxygen give rise to hydrogen peroxide. 2 gram of hydrogen, 32 gram of oxygen, hydrogen peroxide is 34 gram. So here the masses of oxygen are combined in a fixed ratio of mass. It is in this two example we can discover that the 16:32 is this 1:2 ratio. So the next is Gay-Lussac's law of definite proportion. When gases combine or produced in a chemical reaction, they do so in a simple ratio by volume, provided all gases are at the same temperature and pressure. So if you combine any gases in a reaction by simple volume, all the gases will be same at the same temperature and the pressure. So at the STP conditions, there is no change. Thus, 100 ml of hydrogen combined with 50 ml of oxygen to give 100 ml of water vapor. Hydrogen plus oxygen give rise to water. So hydrogen is 100 ml, oxygen is 50 ml, which is give rise to water, which is obtained as 100 ml. So that is what it is stated. If it is combining a simple ratio, provided all gases are at same temperature and pressure. Thus, the volumes of hydrogen and oxygen which combine, that is 100 ml and 50 ml, it bears simple ratio of 2:1. So, Gay-Lussac's discovery of integer relationship is actually the law of proportions by volume. So, it is the law of direct definite proportion is with respect to mass. So, the next is Avogadro's law. Avogadro stated that equal volume of gases contain equal number of molecules at standard temperatures and pressure. So, suppose if you combine any equal volume of gases, they contain the same number of molecules at given the STP condition, that is standard temperature and pressure. Suppose if you combine 2 mole of hydrogen, 1 mole of oxygen, you get 2 mole of H2O. So the next concept is Dalton's atomic theory. So he stated that matter consists of indivisible atoms. So you cannot divide the atoms which are present in a substance. So atom is not divisible. So he stated that all atoms of a given element have identical properties, including identical mass. So if any atom is present in an element, they consist of how many number of atoms are present in that element? We cannot count that atoms. So much atoms also contain the same physical and the chemical properties. Compounds are formed when atoms of different elements combine in a fixed ratio. So if you combine elements in a fixed ratio, you result in compound formation. Chemical reactions involve reorganization of atoms. So in a chemical reaction, what happens? Different atoms undergo organization and they form a new compound. So they are either created, not destroyed in a chemical reaction according to law of conservation of mass. So the next concept is atomic mass. One atomic mass unit is defined as a mass exactly equal to 1/12 of the mass of one carbon-12 atom. Carbon-12 is one of the isotopes of carbon and can be represented as 12C. In this system, 12C is assigned a mass of exactly 12 atomic mass unit and masses of all other atoms are given relative to this standard. So 1 AMU is 1.66056 into 10 power minus 24 gram. So if we consider this mass in terms of hydrogen, you get 1.6736 into 10 power minus 24 grams. So in terms of AMU, we have to calculate the mass of hydrogen atom. So we have to divide it by 1 AMU with hydrogen and the hydrogen mass. So if we divide, we get 1.0078 and when we round off that, 1.008. AMU is now replaced by U, which is also known as unified mass. So the next is average atomic mass. Many natural occurring elements exist as more than one isotope. When we take into account the existence of these isotopes and their relative abundance, the average atomic mass of that element can be computed. For example, carbon has following 3 isotopes with relative abundances and masses. So 12C, the relative abundance is 98.892 and the atomic mass is 12. For 13C carbon isotope, it is 1.108 the abundance in terms of percentage. And the atomic mass unit is 13.00335. And the isotope 14C, the relative abundance is 2 into 10 power minus 10, that is 14.00317. From the above data, the average atomic mass of carbon will come out to be, if we add all the relative abundance along with the atomic mass unit, we have to multiply and all this, if we sum it together, we get 12.011 unit U, that is the atomic mass of carbon. So the next is molecular mass. Molecular mass is the sum of atomic masses of the elements present in a molecule. It is obtained by multiplying the atomic masses of each element by number of its atoms and adding them together. Example, molecular mass of methane, which contains 1 carbon atom, 4 hydrogen atom, which is obtained as below. So molecular mass of methane is CH4, that is 12.011 U of carbon, that is atomic mass, plus 4 times the hydrogen, that is 1.008 U, you get 16.043 units. So formula mass. Sodium chloride do not contain discrete molecules as their constituent units. In such compounds, as they do not contain any other molecules, they contain ions such as positive and negative ions. Positive is sodium ion, negative is chloride ion. So thus the formula mass of sodium chloride is atomic mass of sodium plus atomic mass of chloral, that is 23 plus 35.5, you get 58.5 unit. Mole concept. 1 mole contains exactly 6.022140076 into 10 power 23 elementary entities. This number is fixed numerical value of the Avogadro constant Na when expressed in the unit per mole, and it is called Avogadro number. The amount of substance, symbol N of a system, is a measure of the number of specified elementary entities. So these elementary entities may be an atom, molecule, ion, or an electron, and any other particle which is specified to that group. So it may be also concluded that mole of the substance always contains the same number of entities, and it does not depend upon the substance. The mass of carbon-12 atom was determined by a mass spectrometer, and it was found to be equal to 1.992648 into 10 power 23 gram. So 1 mole of carbon weighs 12 gram. The number of atoms in it is equal to 12 gram per mole. That is equal to 6.022 into 10 power 23 atoms per mole. So this number is known as Avogadro's constant. We can say that 1 mole of hydrogen atoms is equal to 6.022 into 10 power 23 atoms. So 1 mole of sodium chloride is also contains of same 6.022 into 10 power 23 formula units of sodium chloride. Water molecules also 6.022 into 10 power 23 water molecules. The mass of 1 mole of a substance in gram is called its molar mass. So molar mass of water is, we have to write the mass in terms of grams. So the mass of water is 18 gram. So 18.02 gram per mole. Molar mass of sodium chloride 58.5 gram per mole. So the next concept is concentrations in solutions. So how the concentration in a solutions are expressed by a mass percent, mole fraction, molality and molality. So the next is percentage mass of an element. Number of atoms multiplied by atomic mass of element divided by the formula mass multiplied by 100. Example, formula mass of Fe3O4, that is 232. So percentage of Fe is 3 into 56 multiplied by 100 divided by 232. You get 72.5%. Percentage of oxygen is 4 into 60 by 232 into 100. That is around 27.5%. So this is the how we calculate the percentage composition of an element. So the next is empirical formula and molecular formula. Empirical formula, it represents the simple whole number ratio of the number of atoms present in a molecule. Molecular formula represents actual number of atoms present in a molecule. Molecular formula is empirical formula multiplied by N. N is molecular formula mass by empirical formula mass. If we divide, you get some whole number or a ratio, that is the N. A compound contains 4.07% of hydrogen, 24.27% of carbon and 71.65% of fluorine. Its molecular mass is 98.96 gram. What are its empirical and molecular formulas? So we are solving a problem here. So we have to note down all the relevant table in the table. Element is carbon, hydrogen, chloride. We have to note down the percentages. Carbon is 24.27%. Hydrogen is 4.007%. Chlorine is 71.65%. And the atomic mass is 12. For hydrogen it is 1. For chlorine it is 35.5. So the relative number of moles is 24.27. The percentage divided by the mass, 12. You get 2.02. And the same for hydrogen and chlorine. So you have to divide this simple ratio by taking the lowest number of the values obtained. So in these three, the lowest is 2.02, which we have got in both. So 2.02 by 2.02, you get 1. 4.07 by 2.02, you get 2. 2.02 by 2.02, you get 5. The empirical formula in CH2Cl is 12 plus 2 plus 35.5, you get 49.5. So N is molecular formula by empirical formula mass, you get 98.96 by 49.5, that is 2. So if you multiply with the empirical formula, the N value, you get the compound formula as C2H4Cl2. So the next is stoichiometry calculation. So let us consider the combustion of methane. A balanced equation for this reaction is given below. CH4 plus 2O2 give rise to CO2 plus 2H2O. Here, methane and dioxygen are called reactants and carbon dioxide and water are called products. The coefficients 2 for O2 and H2O are called stoichiometric coefficient. Similarly, the coefficient for CH4 and CO2 is 1. They represent the number of molecules taking part in the reaction which is formed in the reaction. So, according to the above chemical reaction, 1 mole of CH4 contains 2 mole of oxygens and to give 1 mole of carbon dioxide and 2 moles of H2O. 22.7 liter of CH4 reacts with 45.4 liter of oxygen to give 22.7 liter of CO2, that is carbon dioxide, and 45.4 liter of H2O. 16 gram of CH4 reacts with 2 times multiplied by 32 gram of oxygen to give 44 gram of CO2 and 2 into 18 gram of H2O, and which is interconverted as mass to moles, moles to molecules. So the next is, what is limiting reagent? The reactant which is present in the lesser amount which is get consumed after some time, and after that no further reaction takes place whatever the amount of the reactant is present, and the reactant which is totally consumed in the reaction. Here first the reactant is consumed which amounts the product form which limits, and this therefore is called limiting reagent. So the concentration is expressed as mass percentage, mass of the solute by mass of the solution into 100. An example, a solution is prepared by adding 2 gram of a substance A to 18 gram of water. You have to calculate the mass percentage of the solute. Mass percent of A is mass of A by mass of solution multiplied by 100. So it is 2 gram by 2 gram of A plus 18 gram of solution. You get 2 by 20 gram into 100, that is 10%. Mole fraction is the number of moles of the component which is divided by the total number of moles of solute and salt. So moles of component by total moles of the solution. XA is equal to Na by Na plus Nb, and Xb is equals to Nb by Na plus Nb. Moles of the solute by moles of the solvent. So Wa into Mb, Wb into Ma. So you get around Wa into 1000 by Wb into Ma, and you get the above calculation. We have to use this in the calculating the problems. Molarity. So number of moles of solute per liter of the solution. So molarity is moles of the solute in terms of liters. So moles is mass of the solute by molar mass. So an example, what is the molarity of a 250 ml solution containing 0.35 moles NaCl? First we have to convert it into liters. It is given in ml. So 250 ml, if you divide it by 1000, you get 0.25 liters. Now as it is in number of moles they have given, that is 0.35 moles divided by liters. So we have calculated in liters, that is 0.25 liters. You get the above answer, you have to calculate that and comment below. Molality. So molality or molar concentration, it is the amount of substance dissolved in a certain mass of solvent. It is defined as moles of a solute per kilograms of a solvent. So units of molality are m or mole per kg. So the formula to calculate molality is moles of the solute by kilograms. In molarity it is liters, in molality it is kilograms. I hope you got this lecture understandable. If you have any questions or doubts, feel free to comment or email us. Goodbye students, ask us anything from AskPrep. Thank you.